simple line drawing algorithm. Normally what we do, we first calculate delta x and delta y by considering x1, y1 and x2, y2. So x1, y1 is the starting point and x2, y2 is the end point of the line. So using that x1, y1 and x2, y2, first we calculate delta x and delta y. First assign x and y, x1, y1, and then calculate delta x and delta y by x2 minus x1, y2 minus y1, and then we calculate the slope of the line. How we calculate the slope of the line? Y2 minus y1 divided by x2 minus x1. So that slope is generated, and that slope minus 1/2 we consider as the error. And using that error, we calculate the x1, x and y values, and accordingly that set pixel using 1 by 1 point is displayed on the screen. Okay, so that is simple line drawing algorithm. So in simple line drawing algorithm, we use m is equal to delta y by delta x. So automatically it result in floating point number many times. And also error is calculated m minus 1/2. So error is also reinitiated or generated in the floating point number. So instead of that, for implementation purpose, we use Bresenham's integer line drawing algorithm. Okay. If you want to implement that one also, simple Bresenham's line drawing algorithm, it is okay. But for implementation, integer Bresenham's line drawing algorithm is a simple one. So Bresenham's integer algorithm for first octant that is given here, x1, y1, x2, y2. Assume that both are not equal, correct? And here again the same, x is equal to x1, y is equal to y1, and we calculate delta x and delta y using the same method, x2 minus x1, y2 minus y1. Only the difference is that instead of calculating the slope and using that slope for error term, calculation of error term, here we use error is calculated with 2 multiply with delta y minus delta x. So automatically every time the error is in integer value. Error is always integer value. Begin the main loop 1 to delta x, set pixel, and then if error is greater than 0 means error is positive. If error is positive, whenever we calculate that error, if it is positive, then increment the value of y. See, every time here I write it with annotation. Every time x and y values are there. Suppose now it is x1 y1 or xi yi. I call it is xi yi. Okay. The next one that I am going to use is xi plus 1, xi yi plus 1. But at this time, whether to increment both xi and yi, that depends upon the error term. Okay. If error term is positive, then only we increase the value of y by 1. Okay. If error term is positive, the next one is xi plus 1 and yi plus 1. But if it is not positive, if it is negative, then y is not incremented. If the error term is positive, then only y is incremented. If error term is negative, then y is not incremented, only x is incremented. So x is equal to x plus 1, and again the error term is calculated. So x is equal here, if the error term is negative, xi plus 1 is there, but y remains as it is yi, whatever the previous value. That simple algorithm is there for integer Bresenham's line drawing algorithm. So the pseudocode is already there in the algorithm, only you have to implement it with the C language. So that is another thing is that here, if delta y and delta x, when we calculate, if delta y is greater than delta x, then exchange the value of delta y and delta x. Otherwise, it gives the wrong result. Why? Because it is in the first quadrant. So if delta y is greater than delta x, then exchange the values of delta y and delta x initially during these calculations. If delta y is greater than delta x, then exchange the values of delta y and delta x. So that is simple Bresenham's line drawing algorithm that already we have studied. One example already we have seen 5 to 8 and suppose 9 to 11 we want to draw. So first 5 and 8, next one is 6 and 9 means both x and y are increased. Why? Because error term is 2 which is positive. Then next one 7 and 9 means you can observe here only x is increment, y is not increased. Then here both x and y are increased 8 and 10. Then 9 and 11 both x and y are increased here. So depending upon the error term, the value of x and y are increased. That simple algorithm you have to implement. Clear? Okay. So first we need to draw line function, a separate function. You can use any method, not necessarily that the same, but the algorithm should be same. The pseudocode the same sequence you have to use here. So int here x1 y1 x2 y2 these are the end points of the line, and the same you can observe here x is equal to x1 y is equal to y1, delta y and delta x is calculated. Error is calculated 2 into delta y minus delta x, and then from 1 to delta x. Okay, according to the algorithm, for I is equal to 1 to delta x, then perform. So here set pixel is there, instead of that put pixel is used here. Why? Because we are going to put that pixel on the screen, and the 7 is the color used for that line. You can use any color. Delay is used here 75. Why? To show that one by one the point is selected. While e is greater than 0, according to the algorithm, while error term is greater than 0, then increase the value of y, otherwise only increase the value of x. In the main function, again the drivers, detect drivers, gm mode, init graph, then enter the first coordinate of the line, that is x1 y1 with printf scanf. Enter the coordinates of the second point, that is scanf. Again using printf scanf we enter x2 y2 and call the function draw line x1 y1 x2 y2, and then that function call this line and print one by one point, get ch, close graph, and return 0 as we use in normal program. So in this way, the same algorithm you can observe here, the same algorithm is implemented here. It's a 10 to 15 minute task, remember that. The implement, now I execute it and see the result. Okay, so enter the points. I use here 100, 100, 250, sorry. Enter the first coordinates 100, 100, 250, 250. You can observe here one by one the line is generated, one pixel at a time. Why? You can see here I use delay of 75. If delay is not used, directly you can see the output, the line is generated. Suppose I increase this delay by 100. I change the color to yellow. Okay, yellow still happen. Next, execute it again. Build and run as changes are made there. Use again 100, 100, 300, 300. You can observe yellow line one by one pixel at a time. You can see here the delay 100. Clear to everyone? So the ninth assignment, you have to implement the circle generation algorithm. Now the circle generation algorithm that we have seen, that is only for first octant. See, that is only for first quadrant. Sorry, this one only, and then it is reflected. So this one is only generated. through our algorithm that we have seen. So if x is equal to 0 and y is equal to r, x is equal to 0 and y is equal to r, it start from here to here, it's a clockwise generation. And if y is equal to 0 and x is equal to r, then it is an anti-clockwise generation of the circle in the first quadrant. The algorithm for that we need, see, for example, this is our point. Okay, so suppose this is our point x and y. The next point that he has to be generated on the circle is either this one, either this one, or either this one. So this is horizontal point where x is increased but y remains as it is. This is diagonal point where both x is increased and y is decreased, and this is the vertical point where x remains as it is and y is decreased. So that part we covered at the time of theory lecture. Again, see, suppose this is our point on the circle already there. Then the next point to be selected on the circle, whether MH, MD or MV. MH means horizontal. If horizontal point we are going to select, then x is increased by 1, y remains as it is. If diagonal point is going to be select, then x is increased by 1 and y is decreased by 1. And if the vertical point we are going to select MV, then x is remains as it is and y is decreased by 1. So that simple method is used, and for that equations we have seen. Again, I am repeating, on the YouTube the video available for circle generation algorithm, my video, you can refer that or use that video, listen it again if you have any doubt. Now see here, this is the algorithm that we are going to implement. Bresenham's incremental circle algorithm. So here again x is equal to 0 initially and y is equal to r, means what? Start from this point and then generate the circle in this way. Start from this point and generate the circle in this way. X is equal to 0 and y is equal to r. Then delta I is calculated. Limit is equal to 0 because up to 0, that y becomes up to 0, we are going to implement it or execute it. So until yi is greater than or equal to limit, until yi is greater than 0, we are going to execute it. When yi is becomes equal to 0, becomes equal to limit, we are going to stop there. So that simple is used, method is used here. So at every point xi and yi, so it is start from here. So which point to be? Either horizontal, either diagonal or either vertical. That point, how to select it? For that, the delta I whatever we calculated, we are going to compare. If this delta I is less than 0, then we calculate small delta, 2 delta I using this equation. How that equation comes, that also we covered at the time of theory. Then we use any one of the two cases, determine any one of the two cases. So it is given here in simple way. So if this delta I whatever calculate is less than 0, means if it is a negative, then we calculate small delta. If this small delta is less than or equal to 0, then choose horizontal. If this small delta is greater than 0, then choose the diagonal point. Similarly, if delta I is greater than 0, means if it is a positive, then calculate delta dash. If this delta dash is less than or equal to 0, choose diagonal point. If this delta dash is greater than 0, choose vertical point. And if delta I is equal to exactly 0, then choose the diagonal point. So in this way, the simple algorithm means step by step the algorithm we have seen. The pseudocode is available. So again you have to convert that pseudocode in the C language or C program and execute it using these simple calculations. So that calculations are given in the pseudocode. So again I am explaining delta is less than 0, then either choose MH or MD. So how to choose the MH? If delta I, small delta I, whatever we calculated here, if it is less than 0, then call MH. And if it is otherwise, it is greater than 0, then call MD, means the diagonal. If delta I, big delta is If this delta I is greater than 0, then choose either diagonal or vertical. So calculate delta small dash. If it is less than 0, then call the MD. If it is greater than 0, then call MV, vertical point. If delta I is exactly equal to 0, then call diagonal points. Now for that, these subroutines MH, MD and MV we need to write. MH, MD and MV, these subroutines we need to write. So that pseudocode is also available. What is the subroutine for MH? For that, in MH we increase the X value, Y remains as it is, and again we calculate delta I. In diagonal we increase the value of X by 1. In diagonal, we increase the value of X by 1 and decrease the value of Y by 1. And again, we calculate the delta I. In vertical, we decrease the value of Y by 1, X remains as it is, and we calculate delta I. And here we finish the algorithm. So that are the only 3 points we need to remember. Either we have to go horizontally, diagonally or vertically. And where to go, it depends upon this delta I. If it is negative, then either horizontal or diagonal. If it is a positive, either diagonal or vertical. And if it is equal to 0, then only diagonal. So I am going to show you the expected output for this. See, on internet, ready-made algorithms are available, but that algorithms are not with this pseudocode. I observed that algorithms are not with the same pseudocode. There are different methods are used. You have to implement the same pseudocode here. So here you can observe that again 2 points are made here. 2 lines are get x max by 2, yc is equal to center. Xc means center of the x coordinate, yc is the center of the y coordinate. How we calculate it? Get max x by 2 and get max y by 2. Why we use this? To draw a line horizontally and vertically so that we can show the result in the first quadrant only. Okay. Now once we how that line is drawn, 0 to get max, x by 2, y by 2, then using these 2 lines, horizontal and vertical line we can draw, and that already you have drawn in the previous practicals of 2D and 3D. So using that to first draw horizontal and vertical line. Here to draw the circle, what is important? We require the radius. We require the radius of the circle. XC, YC we consider it is center of the circle. 1 minute, I will use annotation here. Okay, so this is suppose our horizontal and vertical line. So we are going to start the circle from here. Okay, and in this way. So XC, this is the center we need to consider. What is this center? It is get max x by 2 and get max y by 2. That is XC and YC. X center and Y center. So that using that means that is our origin, and then this is the R radius, which is the value of Y. And x is equal to 0 initially according to our algorithm. X is equal to 0 initially and y is equal to r. So same method is used here. Then y is equal to r. xi is equal to 0 and yi is equal to r. Limit is equal to 0 because we are decrementing the value of y, which is equal to r, every time whenever required up to 0. When it becomes equal to 0, stop there. Then here the while loop is used. First di is calculate delta I. Instead of that we use here di variable. First, according to this algorithm, whatever here given 2 into 1 minus r, the same delta is calculated. Put pixel xyc yellow, the color of the circle. First start with the xyc 0, the center. While yi is greater than or equal to limit until it becomes equal to 0, execute this. When it becomes equal to 0, stop. Put pixel first. Xi plus c means xi plus 0, c minus yi and yellow. Color give yellow. Again I use here delay. This is the first put pixel. Delay and then we calculate the remaining. If delta is less than 0, then calculate delta 1. Small delta, as we use in pseudocode, delta 1. If this delta 1 is less than 0, then MH means use horizontal pixel. If this delta 1 is greater than 0, then diagonal pixel. Else means if delta I is greater than 0, then delta I calculate delta 2. So if it is greater than 0, then if delta 2 is less than or equal to 0, then diagonal. If delta 2 is greater than 0, vertical. As we use here. If this one delta dash is less than 0, call diagonal. If it is greater than 0, then call vertical. Else, if delta I is equal to 0, then directly call the diagonal points. Get CH. It's a very simple algorithm. If you see, if you execute or use all this as it is, only you have to convert it into C programming. Nothing else is there. You can observe here simple calculations are there. Directly MH, MD, MV, these calculations are put here in if else loop. While you are performing this practical, if else loop is very important. If you miss any one if else or write any one wrong if else loop, then program will not execute. So here I am going to show you the execution. I put here the delay, more delay. Okay, so first you have to give the radius. I give the radius 100, and now you can observe here. One by one the pixel is generated according to the algorithm only, as it is pseudocode is implemented here. Only first quadrant. After that, the next one is the after reflection through the x-axis, then after reflection through y-axis. That is the next part. If you want, you can implement it. But at least first quadrant you have to implement. That is the very important part of circle generation algorithm. So don't use the program, ready-made program on the internet. It's a very simple part. Pseudocode is available in the PPTs which I have uploaded on the Moodle. So directly use that pseudocode and accordingly generate write your program in C, but save it as a .cpp as we are using the code block. Is it clear?